Okay, so good day students, good day everyone, and so welcome back in our online world. And by next day we have our next week we have our um, face-to-face class. Okay, so let's start. Okay, so our topic for today it's all about the transportation model. Okay, so it's all about transportation, mga pagbiyahe sa mga different products or supplies. Sige. So first, what is a transportation model? Okay, what is the transportation model? Okay, so first, transportation model is a special case of the linear programming problem. So in which the main objective is to a product, transport a product from a various sources, to a various destinations at total minimum cost. So that means we need to transport that specific supply, okay, by a different sources or different company to a specific destination, okay, and a minimum cost. Okay? So in a transportation model, the sources and the destination are known. So the supply and the demand at each source and destinations are also known. So it is designed to find the best arrangement, okay, for transportation such that the transportation cost is minimum. Okay, so why is it we need to study this topic? It's all about the transportation. Because class, the importance of this transportation model is we need to minimize the cost, okay? Because 'di ba, meron tayong mga different destinations. Okay, kung dili man nimo ma-minimize ang cost, dako ang imong magasto. So that's why we have the transportation model or the transportation problem. So the application of this problem, okay, so it may be a beneficial and different or in a various type of companies pagdagko ng kumpanya gani. So that is why we need to apply the transportation model. Okay, sige. So the transportation problem or TP, okay, denoted by TP, is an important linear programming model that arises in several contexts and has deservedly received much attention in literature. So the transportation problem is probably the most important special linear programming problem in terms of relative frequency with which it appears in the application and also in the simplicity of the procedure and developed for its solution. So the following features of the transportation paradigm are considered to be most important. So the TP or the transportation problem were the earliest class of linear programming discovered to have a totally unimodular matrices and integral extreme points resulting in considerable simplification of the simplex method. So the study of this transportation problem so laid the foundation for further theoretical and algorithmic development of the minimal cost network flow problems. Okay, so ito, the transportation modeling. So in the transportation modeling, so find the last cost, di ba? The last, okay? Mubo or pinakabaratong cost means of shipping supplies, okay? Supplies from a several origins to several destination. Okay, so by shipping a supply. So KNOTs in using transportation modeling, so the origin points and the capacity of supply per period at each and the destination points and the demand per period at each and the cost of shipping one unit from each origin to each destination. So we have before we proceed in our discussion, okay, so let's have our objective objective for today po. So after completing this chapter, so the student will be able to, okay, identify a transportation problem and state its assumptions and formulate the problem in transportation model and write the equivalent linear programming problem and generate the initial feasible solution by the northwest corner rule and the Gradstone method and the Vogel's approximation method and apply the transportation model in business operations. Okay? So, sige. So, first, illustrate the transportation model. Okay? So, it shows the relationship of the source and the destination, and the goal is to select the shipping routes and units to be shipped to minimize the transportation cost. Okay, so first, let's have our what you call this, source. So ito yung mga sources, different company that making the products or the supplies. Ito yung mga sources. Example, meron tayong sources like Nokia, iPhone, or Vivo, or Realme ba. So, meron silang capacities kung magkano ang kanilang um, supplies. And in the destination naman is ito, yung mga store. So, ito yung mga main sources. Okay, so ito yung mga um, mag-shipping sila going to the different stores. Okay, ito. Pwede dito, pwede dito, and pwede dito. So class, meron siyang mga requirements or yung demand ng mga different stores. 'Di ba? Meron example lang. Yung store A natin is nag-need sila ng dalawang Nokia or tatlong Nokia. So depende lang. So shipping out 'yan from the sources to the different destination. So the question is, so what are the cheapest routes, okay, the pinakabarato daw nga routes to send a certain number of product from a certain number of suppliers to a certain number of destinations. And to answer this, we need to consider several things beforehand. Okay? So the number of sources and their capacity to supply the products to distribute. And B, the number of destination and their demand. 'Di ba? So the number of case, 'di ba? In A, so the number of sources. So ilang sources ang magdi-deliver ng mga products and their capacity. So magkano yung mga products na the availability of the products to supply the products to distribute. And in B, so what are the number of the destination? Okay, ilang store ang nag-need ng mga product and what are the requirements of the different stores at or magkano yung mga requirements nila, di ba? So, di ba pwede nga moingon dayon ka nga daghan ko og need ng mga products. So meron silang mga demand lang. So depende lang, depends in the locality, di ba? So C, the per unit cost, okay. So syempre meron yang mga involved na kwarta. So the per unit cost of shipping the products from a certain source to a certain destination. Sige. So let's have the example. So the WSS company sells desktop computers to IT companies, okay, companies in Metro Manila, okay, and ships them from three distribution warehouse located in three different areas. So the company, okay, is able is able to supply the following numbers of desktop computers to IT companies by the beginning of the year. Okay. So the distribution warehouse, so we're in the making or the source, okay, the source. Ito yung mga source. The warehouse 1, okay, and the warehouse 2 and the warehouse 3. So, ang kanilang mga supply, okay, yung supply ng warehouse 1, so mayroon silang supply or given supply 150, okay, desktop, okay, or PC, mga personal computer. And the warehouse 2 given 200 um, supplies or the desktop computers. And the warehouse 3 50 desktop. And the total of the supply class is 400. And the IT company, okay, the IT company, okay, so yung mga product, okay, ay yung mga name ng company na nag-need, okay, nag-need, okay. So ito, so the demand of the desktop computers in the AUS link, okay. So name of the company yan ha. Okay, so ito 100, okay. The SGS networking INC is 80 yung demand for the desktop computers nila, and the RFS data limited so 220, and the total of 400, okay, demand the that specific company, the IT company. Okay, so ito yung mga from, okay, so ito yung mga table class. Okay, so warehouse 1, ito yung mga warehouse 1. So ito yung mga warehouse natin. Okay, and ito yung mga IT company. So the AUS link and the SGS networking INC and the RFS data limited. So ito yung mga destination, okay, of the supplies. Okay, sige. So given lang ito ha. Ito yung mga given. Okay. So next, and the solution. So with cost minimization as a criterion, so the company wants to determine how many desktop computers should be shipped out from each warehouse to each IT company. So construct the linear programming model. So let 1, okay, let 1 is equal to warehouse 1, and let 2 warehouse 2, and let 3 the warehouse 3. And so let A is equal to AUS link, okay, store, and let B the SGS networking incorporated, and sorry sa INC ha, so incorporated, and C is equal to RFS, okay, let's see RFS data limited. Okay, so this is the illustration. Okay, so ito yung mga warehouse and also the IT company. Okay, warehouse 1, warehouse 2, and the warehouse 3. So in the warehouse 1, okay, 150 units of the PC or the personal computer or desktop, okay, and the warehouse 2, 200 units and 50 units, and the IT company 100 units, 80 units, and 220. So ito yung mga need nila, ito yung mga number nila. Okay, yung IT company na 1 is nag-need sila ng 7, and the warehouse 2 nag-need sila ng 10, and yung warehouse 3 is nag-need sila ng 6. Is as you can see, naka distributed siya, evenly distributed siya. It shows that the network graph of the transportation problem. For example, the variable x sub 2a represent the amount flow in the arc leading from the warehouse to a US link. Sige. So observe the variable representation in each square. Okay? So class, so take note ha. So this is the sources. So ito yung mga sources. So ito yung mga sources. And ito yung mga destination. Okay, yung mga destination. Okay. Okay, so just in this row, okay, just write 1, 2, and 3. And the destination of that in the destination, so just write A, B, and C for the destination. Okay, so in the x sub 1 A 7, the x sub 1 B 5, and the x sub 1 C is 9 is equal to 150. So this is our supply. Okay, the availability of the supply 150 from the warehouse 1 and 200 from the warehouse 2 and 50 units from the warehouse 3. Okay, and the demand of each company, okay, 100, 80, and 220, so is equal to 400. Okay, 400 yan. Okay, sige. So in this row, x sub 2a is 10, x sub 2b is 12, the x sub 2c is 10, and the x sub 2, okay, ito yung 200. X sub 3a 6, x sub 3b 3, and the x sub 3c is equal to 14. 50 yung supply. Okay, sige. So, class, okay, the X sub AA, warehouse 1 to company A. Di ba? Warehouse 1, company A. X sub 1B, okay, warehouse 1 to company B. The X sub 1C, warehouse 1 to company C. And the X sub 2A, warehouse 2 to company A. And the warehouse 2 from the company B. And the warehouse C, okay, where x sub 2c warehouse 2 to company C, and the x sub 3a warehouse 3 to company A, and the warehouse 3b warehouse 3 to company B, and the x sub 3c warehouse 3 to company C. Sige, so that's the LP formulation. The transportation about it is follows. Okay, the objective function class. Okay, okay, so just copy, okay, in our tableau, the transportation model tableau. Okay, the x7 x sub 1a plus, so yung operation that will be used, okay, that will be used is our addition. Sige, 7x sub 1a, 5x sub 1b, then plus 9x sub 1c, and 10x sub 2a, and plus 12x sub 2b, plus 10x sub 2c, plus 6x sub 3a, plus 3x sub 3b, plus 14x sub 3c. So subject to, okay, minimize or the constraint. Okay, so that will be our structural constraint. Ito. So x sub 1a plus x sub 1b plus x sub 1c is equal to 150 units. So ito yung copy lang ang supply. The x sub 2a plus x sub 2b plus x sub 2c 200. So ito yun. Copy mo lang ito, yung mga variable. And ito naman, x sub 3a plus x sub 3b plus x sub 3c is equal to 50. And next naman, the column naman, ito, lahat ng column ni company, okay, x sub 1a plus x sub 2a plus x sub 3a is equal to 100. Total of demand of the company A. And column B, so x sub 2b, x sub 2 ito, plus x sub 2b plus x sub 3b is equal to 80. The demand of the x sub 2b is equal to 80. And the x sub 3c, okay, ito, x sub 1c, x sub 1c plus x sub 2c plus x sub 3c, so lahat ng column ni C, just copy, is equal to 220 demand of the company C. Okay, sige. The tawag nito, non-negativity constraint. So x sub I j is less than or equal to 0. And now, so let's proceed the different types or the methods in establishing the initial and the optimal feasible solution of the transportation model. Okay, so first, okay, we have the first method pala, the northwest, okay, the northwest corner rule or the NCR. Okay, NCR yan na, the northwest corner rule. Okay, so the procedure of the northwest corner rule. So for obtaining an initial feasible solution to a transportation problem, that starts with allocating units to the upper left-hand corner and ends in the lower right corner of any transportation problem. So class northwest, di ba? So di ba familiar, di ba? Kung aton siya ibutang kung magkumpas ta, di ba? Meron tayong north, ito yung north, south, and the east and west. Okay, di ba? So, di ba? Northwest corner. So dito yung northwest corner. So dito na corner class. Okay, so dapat yan yung kunin natin. Sige. So example number 1. Okay? So the same problem. So with cost minimization as criterion, so the WSS company wants to determine how many desktop or computers should be shipped out from each warehouse to each IT company. So find the initial feasible solution using the northwest corner rule and the grading method and the Vogel's approximation method. Sige. So step 1. So in order to solve a transportation problem, so it is necessary to follow the following steps. Okay? Establish the mathematical model for the problem and establish the transportation tableau. Okay? So familiar, no? So this is our um, sources from warehouse 1, warehouse 2, warehouse 3, and different company naman. Okay? A, B, and C, and the supply, and the demand. And ito yung mga destinations nila. Sige. So, just copy the objective function. Okay? The minimize cost. Siyempre, transport man taog ka ng product. So, it should be minimize the cost para makabarato ta sa cost. Di ba? Eh, mahal kayo. Di ba? Gasolina pa lang daan. Okay, tao. Gasolina, tao, your um, tawag ni tracking, 'di ba? Pag tracking pa lang daan. So, syempre, we need to minimize the cost of that specific problem. Sige. So, here are the steps in establishing the northwest corner rule or NCR. Okay, step number 1. Start in the upper left-hand corner or the origin 1 destination A, X sub 1A, and allocate as many units as possible to this cell. So use as much supply from origin A as possible to satisfy the demand and the destination. So this means that the amount of allocated is the minimum of supply at 1 and the demand at A. Okay, then number 2. So reduce the available supply at the current origin and so unsatisfied demand at the current destination by the amount of deallocation. And number 3, so step number 3, identify the first origin with available supply. So this is either the current origin or the one directly below it. And number 4, identify the first destination with unsatisfied demand. So this is either the current destination or the one immediately to the right of it. Number 5, allocate as in step 1 as many items as possible to the route so associated with the origin destination combination were identified in step 3 and 4. Sige. So ito na yun, ito na ang mga specific solution in the transportation problem. Okay, step 1. Okay, so formulate the transportation tableau. Okay, so ito yung transportation tableau. So beginning in the cell, 'di ba? Northwest, 'di ba? NCR, the northwest rule. Okay? the Northwest Corner Rule or the NCR. Okay, di ba? So, beginning in the cell X sub 1A. So, ito yung X sub 1A. So, dito tayo mag-start. Okay? The X sub 1A, which is the upper left corner of the tableau. So, we allocate 100. So, in the X sub 1A, yung demand nila ni company A, so the demand of company A, so they need 100 units of desktop, diba? The desktop. So, ito yung X sub 1A. So, allocate natin class or plug. Okay? Plug in 100 dito. Okay? So, they need X sub 1A, they need 100 of computers. So, yung demand nila, so minus na lang. 100 minus 100, so 0 na. So, crash out mo lang yan. Okay? So, the supply of warehouse 1, di ba? Meron silang supply na 100. Di ba? So, 100 minus 100, 150 minus 100, so meron silang remaining na 50. Di ba? So, ito. So, nag-satisfy na. So, crash out mo lang ito. Ano ito? Okay, so exhausting the demand in column A and leaving 50 units of supply in row 1. Okay, di ba class? Meron silang remaining na supply na 50. So, i-remain mo lang dyan sa may X sub 2A. X sub 1B. So, ito, dito. Okay? So, staying in row 1, move to cell X sub 1B. Okay, move tayo dito. Where supply is now 50. Diba, meron silang remaining na 50 dito. Nag-minus tayo ng, sa 150, nag-minus tayo ng demand na X sub ni company A ng 100. Okay, 150 minus 100, diba? 50 yung remaining. Okay? So, now, and the demand is 80 units. So, yung demand ni company B, so they need, diba? They need 80, diba? 80 units of the desktop. So, therefore, 80 minus 50. So, yun is equal to 30 units. So, 30 units na lang yung natirang demand. Okay? Demand, crash out pala ito ha. Okay. So, nasatisfy na yung company A. So, dito na lang tayo focus. Okay? Plug in 50 in the company B. Okay? Copy mo lang yung 50. So, yung supply niya class, di ba? 50 minus 50, so 0 na lang. So, wala na. Okay, wala na. Wala tayong supply ni warehouse 1. Okay, crash out na ito. And next, ito na yung natira. Okay, exhausting the supply of row 1 and leaving 30 units in column B. So, meron tayong remaining in the company B. So, meron pa silang need na 30. Okay, so in warehouse 1, wala nang natirang supply. Okay? So, crash out na ito. Sige. Step number 3. Okay, step number 3. So, staying in column B. Sige. Wala na niya, wala na ni pod. Sige. So, staying in column B, move down to cell X sub 2B. So, move down tayo class because northwest corner, di ba? Rule. Okay, move down tayo. So, dito tayo. Sige. Okay na yung nag-satisfy na ito. Nag-satisfy na si company B. A. Si company B na lang. Okay? Sige. Di ba merong remaining na 30 dito? Okay? So, copy mo lang yung 30 na demand. Okay? Demand ni company B dito sa middle. Okay? Sige. Copy mo yan. Stay in column B. Move down to cell X sub 2B where supply is 200. Diba yung supply ni warehouse 2, meron silang 200. Okay? 200 units of desktop. Diba? Sige. And the demand of the company B is 30. Meron pang remaining na 30. So, that is why 200 minus 30, di ba? Allocate 30 units. So, allocate natin yung 30 units na desktop dun sa company B. So, 200 minus 30 is equal to 170. So, meron pang available desktop si warehouse 2. So, therefore, yung 80, wala na yun, di ba? Copy mo lang yun. So, once 200 minus 30 is 170 na lang. So, ito. So, wala na. Okay na, nag-satisfy ng demand ni company B. Nakuha na. Sige. So, ang natira na lang class is ito. Okay? Ito na yung natira. Ito. Sige. So, step number 4. So, staying in row 2. So, staying in row 2 move to the cell X sub to C. Okay? So, ito yung X sub to C. So, ito yung northwest corner rule, di ba? So, ito yun. Wala na yan. Nag-satisfy na na. Nag-satisfy na. So, ito na lang yung mga unsatisfied. Okay? Na cell. So, staying in row 2, move to the cell X sub to C. So, ito yung X sub to C. And allocate 170 units. Okay? So, bakit 170 units? Di ba merong remaining si warehouse 2 na 170 units. So, i-move mo lang yun class, yung 170. So, 170 minus 170, 0 na lang, di ba? Move dito sa X sub to C. And then, so, wala na, di ba? So, 220. Yung 220 minus ng 170. Di ba? So, bawas na. 220 minus to 170 is equal to 50. So, yung remaining na lang is 50. Sige. And merong supply pa si warehouse 3, di ba? Meron pa siyang supply na 50. So, 50 minus 50, okay? 0 na lang. So, that is why 50 na dito. Okay? So, in the step 5, so 50 lang dito. And, okay na. Nag-satisfy na lahat. So, yung naka-highlight na cell or box, yung box na naka-highlight, so i-copy mo yan doon sa ating the total transportation cost or the tableau. So, the total transportation cost for the northwest corner, so the source destination, ito yung mga source destination, the X sub 1A, okay, 100, and they need 7, okay, so 7. So 100 times 7. So total of 700. Okay? The X sub 1B, so 50. 50 times 5. Okay? Ito. 250, and the X sub 2. X sub 2B, ito na 'yon. 30 times 12, 360 cost. And the X sub 2C, ito 'yon. 170 times 10, 1,700. And the X sub 3C, okay, 50 times 14 is equal to 700. Okay? And the total transportation cost, 3,700. Okay, 3,710 pesos. Okay, so that would be the minimization cost of the northwest corner rule. Okay, and that would be all. Thank you.